Hello, hello.
Hey Lucas, good to see you. Hi Ferhan.
Maybe we can quickly talk about the quickly which projects are in the menu today. So everyone has an idea of what kind of projects that we will see, what kind of teams. Maybe Laura can quickly share with us.
Hey
Yes.
everyone. Yeah.
Strapa has asked a question. I mean, to be honest, this is Zoom is also good because you can also ask questions here. Our team will check the questions from Twitch, etc. But you can stay here in Zoom, Strapa, no problem. I mean, it's really up to you. How much you want to interact is according to you. You can decide. But you can stay here. But if you have questions, people who are in the Zoom, please use the Q&A tab under our screen. So you can already do that. Since we will do back to back and like a short sessions, we just want to tell you that um, ask your questions whenever you have, because we may need to immediately start the next one, so we can answer that in between. Okay, so don't hesitate to uh, submit your questions. And Julian is also with us. Hello, Julian. Perfect. So yeah, maybe Lara, you can quickly mention about our menu today.
Yeah. So we'll start with Inkphony, which took the attention on social media, and Lucas Martinic will talk about it. Then we'll continue with Lasertag with Julian, which turns any space into a Lasertag arena. And then we will have Band Together, a rhythm game with microgestures, and then language in real life with Parker, which went for PC and AI usage.
Amazing,
Uh,
amazing. So we have lifestyle projects, games, very interesting. So let's start. I think without further ado.
Okay, so Inkphony, we built Inkphony for, um, well, I guess we started in XRCC in Berlin, which is another hackathon last year, and we built an app that was focused on music learning, where you could, using the Logitech pen, um, kind of like intuitively draw notes on a surface, because the Logitech pen has like this touch point, point where you can just touch surfaces and get that data, that information. So it was very intuitive to do this part here that I'm doing now with hand tracking for the new submission. So it started like that. And we added like a little AI component last time from for previous version, where um, you could also touch something with the tip of the pen when we were like in this AI mode, um, and that will like trigger a screen capture at that moment using the meta. It was not PCA back then. I think it was still a hacky solution that maybe like Julian actually did. That he is here, Julian Triveri. Um, so we were using that to send one frame to Llama 4 back then, and using AI will like generate a sound. So everything was more like more clunky. I think I have another video of that part somewhere. Oh, it doesn't matter. But anyways, for meta, for the star competition, I really wanted to improve that AI pipeline of getting sounds from your environment to use them in the song we are uh, drawing here, that we are creating. And for that, I use the new PCA SDK, the new PCA API that was released and that was worked with like by Roberto and other people that allowed for more capabilities, right? Like we had stereo access, so it was not just a mono image like before, but you can have access to both cameras, so you can get both frames at the same time, which was important for stuff like the shader, where I'm like stretching the object, like here. See, there's a shader that allows for like pinching like a real object around you, and that was definitely possible only with having both images, because if it's only one image and you have just a flat visual, I mean, here you cannot tell because this recording is monoscopic, right? So it's kind of being recorded from one of your eyes. But when you're wearing the headset, that wouldn't look right. So right now it's stereo. So if you go in the headset and you do this, interaction is totally 3D in there. It looks totally like proper implementation. Looks really cool. Yeah, I really want everyone to try this when we release because it's really cool. And yeah, one of those things was not possible before, right? Which is this. So that was one of the things that I wanted to improve. And the other thing was the timestamps that came also with the PCA, with the new PCA package or API, which allows also for like using AI models are kind of slower to like process an image. So if I capture, for example, this environment, I wanted to recognize different objects, right? And here I'm using Gemini 2.5, the vision one, and the thing that is that model takes a little while to recognize images, right? So it takes like 5 seconds or so. So you want it to be running kind of like in the background, like at all times. So that's what I did with this implementation. And the thing that is that when you do that, since you're like constantly moving your head around, you want to save the timestamp of that image that you sent to Gemini or whatever AI model, right? With a timestamp to be able to later retrieve what was the position of your head in the environment. So then you can align everything properly. So that was another thing that was possible now with the timestamps of the frames. So everything can be aligned properly using depth. So those two things were like improvements we wanted to do that we did. We created like a whole system that's doing this in the background, that creates candidates of different things that are around you, that filters, so we don't get too crowded, or it's like a whole algorithm there that keeps it in control in a way. So it works really cool. And the other thing that we did was moving everything to hand tracking, because we wanted to do this gesture more like with a pinch. It's more interesting. So what's happening here is like you see a camera is detected, a phone is detected, this other phone here is detected, and when you pinch it out like that, an icon also generated, which then you can plug into the UI of this music. This staff is called, and use it as an instrument. Let's use the default right? But then if you extend that and you plug a phone, for example, you get a different sound that was generated from that object. So all generated in real time. So it really kind of adapts to your environment, depending on whatever you have around you. You can create different sounds, different instruments. Yeah, this was recorded like a couple days before Christmas, so that was awesome. And then let me plug some other sound here. Yeah, cap. Yeah, the cap sound is really nice. Yeah, the sound is also cool. It's like a bass. And yeah, that was like the main things we worked for MetaStart. I was definitely more like going for best PCA implementation with this work. That was like the objective, but I guess it turned out so good that we ended up winning the one of the three big categories, which was best lifestyle app. So the next plan now we have with this prize is basically keep working on the app and releasing it. We're gonna release it like probably around March. We already started working, and we have basically already a list of things we want to implement. We're gonna keep you updated. We're gonna open the pre-order soon. It's not gonna be so expensive, so don't worry. And one of the challenges I have now is I cannot use Gemini because that will be too expensive. So I will use Unity Inference, which is like the local AI system that you can run locally. So you can plug a trimmed down model in Unity and build it with your app, and it will run locally in your headset. So that's what I'm currently working on. Very promising so far. I think it can run almost as good with open source models like Florence 2 that are also like one-shot models, like zero-shot models, sorry, where they just kind of recognize anything you have around you without previous training. So yeah, exciting things ahead. Yeah, I think we can just, I guess, start with the questions.
Yeah, we have actually one question from Ray. Basically, he's asking, I mean, maybe he's referring that how you come up with these incredible ideas every year, at least one idea. I think he's also referring to your other project, Lucas, from last year. I don't know if is there any chance that you can also show that one, Color Picker?
Yeah.
I mean, it is already in the, I can also share the link. It's already in
Oh yeah, it's
the
here in
Devpost, so
Devpost.
you can already show on the Devpost. Yeah.
Right.
I mean, XR
Okay.
Qubit as well. That's also another project.
Yeah, I guess this was the first iteration of something similar, which is using your environment as as a palette, right? In this case, it's literally a color palette. In Inkphony, it's more like a sound palette. Yeah, I guess I'm very interested in apps that adapt to your environment or like context aware, right? So depending on where you're sitting, or depending where you're using it, you have like different options, different possibilities. So in this one, yeah, it was also with Logitech, and essentially you could just touch one object around you, and using also Julian's repo initial hack for accessing the camera, I could grab the pixel color, or more like an average of pixels, and then you can use it as a brush, right? Like the color. And yeah, like trying to reply the question from Ray. I guess I just dedicate some time thinking on experiments to do. Sometimes when I go to sleep, or sometimes when I'm commuting or stuff like that, I just go into my head and just start thinking about possibilities, like what are the new packages that were just released, the new SSDKs, and you start like just thinking about what can be interesting or fun to do. Usually something that something that excites me is gonna be something that like is fun and something that kind of pushes a little bit what's possible, what has been done so far, and usually they don't turn into apps. These ideas. This is gonna be the first app that I kind of publish, Inkphony. Usually it's more like inspiring other people to try things, and to see different things that could be possible, right? So it's more like sharing a little video of what was created to people, to get people excited. Yeah.
So I have a question,
Mhm.
Lucas, before we move to the next one. So manipulation of reality, right? What you are doing, or understanding the environment, right? Like, can you give us a little bit of like your perspective of like what what are you expecting, for example, next years or in the next few years that we will be able to do on a wearable device that we can either get the context in a much more depth, in much better depth, or by just manipulating reality. So how you would imagine that we can go beyond this, what we are right now, that you can do with these superpowers? Will there be more superpowers, or are you imagining that we are just starting that within the even existing superpowers that people can explore a lot of ideas? This is just, you just found two, but there are maybe 200 different possibilities. How you are seeing the uh, trend here
Mhm.
that we can maybe
Yeah.
inspire from?
So one of the limitations we have right now with camera access, for example, is that it doesn't cover the full viewport of the headset. So it's still like a limited area in front of you. Um, so once we have access to a full viewport somehow, that definitely unlocks more possibilities, because and especially if we get a higher frame rate. So at the end of the day, it's probably you need faster devices for that, because right now, yeah, it's still limited and still a bit slow frame rate that you gain access to. So you cannot still you can't just yet like modify what you see completely, which is what I'm interested in. Um, you still need to, you are still constrained. So that's why, for example, this works right here, is because usually when you interact with something, that something's gonna be kind of centered in your view. But as soon as I try to do this in my more like peripheral view, it won't work because I don't have access to the camera there, right? In this case, it works because the user will always be facing what they're interacting with. Um, but yeah, like the camera axis is like something like this, right? It's like it's smaller than what you actually see. Um, so it's still limited, but once you have total access, you can start doing all sorts of stuff. Like if we could access like completely what you see on a headset, like I don't know how Meta, for example, does all the like the under the hood processes with all this video and cameras. Probably pretty complex. That's why we can only access certain kind of video feed. But if it was possible to like really access the full thing and modify it with shaders or with code, with programming, I feel like then there's a whole world of possibilities there. You can really start just modifying things around, changing colors of your objects in your room, adding textures to your walls, but like in a seamless way, like it wouldn't look like an overlay or like weird. You could like really make it look like it's part of it.
Are you imagining this real time?
Yeah, I mean, if we could access like a camera,
Stream.
yeah, like a
Stream.
video feed that is the same frame rate that like 72 or 90 frames per second, and it's like the full viewport of what you are really watching, really seeing in your headset. Yeah, then yeah, you could potentially do like what I call like true, like real mixed reality, like this camera access.
Real time mixed reality.
Yeah, yeah, it's like this camera access we have still, I mean, it's cool, but it's still not what we were maybe thinking of
Yeah.
that could be, right? But I guess the devices are still not there, which is yeah, I mean, it just keeps things to be excited about for the future. So that's one of the things,
Okay.
I guess.
Perfect. There's one question. What is the AI name that can run locally with Unity? I think Unity Santas. I don't know.
Nowadays called Unity Inference, I think,
Yeah, Unity Inference. Yeah.
which can run models locally as long as the models are in Onyx format. So it's like a compressed format for AI models. So if you want to run a model, you want to first transform it into an Onyx format. You can probably find how to do it. I don't think all the models are compatible with this workflow, but some of them are. The first, they can be so big. And yeah, one of the models that works well for this kind of stuff is Florence 2, which is an open source one. Well, it needs to be an open source model if you want to make it an Onyx file.
Perfect. As a developer of a standalone VR app, which is not mixed reality, what is the best solution to less jittery and more clean and quality applications in terms of performance? And
I mean, if you keep the performance optimization is the same as in VR, doesn't change. I mean, the mixed reality feed, like the camera feed that when you're seeing your environment is, you cannot improve that if that's what you're asking. You cannot make it less jittery like that video feed. And that's what I'm saying, that sometimes it looks like lower frame rate than actually is when you look with your eyes, right? Or like when you are in VR. In VR, sometimes everything looks super smooth. If you're running at 90 or or higher frame rates, right? But mixed reality, like the pass-through cameras are running at 30 frames per second, and then Meta does something to like create more frames probably, and ends up running at something like 60. I'm not sure, but yeah, it doesn't run so fast, but yeah, you cannot change that part.
Wonderful, wonderful. Perfect. I think right now we are, I think, seeing a lot of interesting use cases. This one is definitely one of the favorite, apparently, for Meta as well. So congratulations again, Lucas, for
Thank you.
making this kind of interesting, inspiring projects. At least once a year, we are having something like a flagship from you. In addition to your 100 projects, prototypes, mission going on. But thanks for joining, Lucas, for today. And we have now another interesting project coming from Julian.
Thank
He's
you.
actually the person that opened up all the camera access possibilities with his 3D Git repo. We all use that, especially I think Lucas, your color picker used Julian's thing, right? Like as far as I remember.
Yeah, yeah. I reached to Julian back then, before the hackathon, to ask him a couple questions, actually. Yeah.
Yeah, amazing. So even before Meta that we were using camera access thanks to Julian's repo. And yeah, now here we are. Julian is with us. Thanks for joining, Julian. And yeah, they have also another very successful projects for the competition, which is, I think, quite interesting. Makes headsets almost like a location-based entertainment device. So Julian, stage is yours. Thanks for joining.
Thank you very much for having me. Can you guys hear me okay?
Yes.
Awesome. Okay. Let me share my screen real quick. I've just installed Zoom, so there's a chance I might have to actually quit and relaunch the app. Maybe not. Okay. It seems to be working. So, yeah. So let me go to the Devpost real quick. So my submission was an update to actually a game that I first created for the Presence Platform Hackathon back in 2024, and it didn't win anything, but I was still super proud of it. And I think this is what Meta does. They run these hackathons so that even if you don't win, you create something that you're proud of, and you're proud enough of it that you want to keep working on it. So they just kind of trick you into creating, entire projects out of these hackathons, even if you don't win. Um, this is what happened in my case. This first version, back in 2024, used the depth API for raycasting against the physical environment. I wanted to see if I could do this and get around the painful process of the room scanning setup that comes with the headsets, because I'd read so many blog posts about, I think it was like Pillow or some other apps that had metrics that showed that half of the users weren't even scanning their room or didn't know how to scan their room for these mixed reality apps, and so they had to make all of these workarounds for people who either didn't know or were not willing to scan their room. And I wanted to make something that just worked. So I tried using the depth API with some to limited success, but found that if I wanted to shoot down long hallways or something, the depth API was not good enough for that because it was only accurate to about 5 to 7 feet. So I later stumbled on some Stack Overflow post about truncated sign distance fields, which are an extremely straightforward way of taking depth information and storing it in kind of giving the headset object permanence, proper object permanence, so that if I walked down a long hallway and I walked back and I shot down it, it would remember that hallway is empty up until this point. The way it works is your environment is represented as a voxel volume, a 3D texture, and each it's a single color. You can append other data to it if you want in the other color channels, but I'm only using one channel. And the value of each voxel represents the distance to the closest surface. And negative values mean that you've passed the surface. So it's the crossing from positive to negative values that actually represents where the surface is, the isosurface. And you can very easily accumulate data from the depth texture into a 3D texture like this, and very easily build a representation of the physical environment. So yeah, this 2024 version only used the depth API without this truncated sign distance field element, which gave it limited accuracy, but it also was a good proof of concept that this kind of low friction setup type of game could work. I then worked on it a ton more, so that I got to the point where it was much more robust. And you could play like proper matches in large areas, and for the most part, ignoring some unfortunate tracking drift with the headsets, which I'm still working on solving. You could have laser battles with your friends, and it would feel reasonably like, you know, the lasers are interacting with the environment, colliding correctly, not just hitting random stuff in midair for the most part, unless you're in an environment with a lot of reflective surfaces that, you know, kind of mess up the depth estimation. And then for this hackathon, I wanted to take it a step further, because one of the limitations of the game is you need other people to play with. And it's kind of hard to find other people who also own headsets in real life. And you probably don't own multiple headsets yourself, so you can't just invite your friends over. So I wanted to see if I could support single player with some kind of zombies experience. But the problem is, in order to do that, I need to support pathfinding somehow. And I didn't want to implement my own pathfinding solution. So I wanted to see if I could use Unity's solution. And in order to do that, I need a mesh of the environment, not just this 3D texture volume, because Unity's built-in nav mesh system is expecting or is built to work off of meshes. So I looked into meshing the environment. I first did this outside of the hackathon using another person's package for I think it's called marching cubes is the technique for meshing a scalar field or a TSDF like this. But it proved to be too slow. It really choked the GPU. So I ended up, for this hackathon, kind of returning to this idea and writing my own system based off of what I think is actually a slightly better technique called surface nets. They're pretty similar to each other. They're both used for meshing sign distance field volumes like this. But you can see I'm in the XR simulator right now, and as I pan the camera around and move around, it is building a mesh around my environment. Now, unfortunately, it creates a lot of triangles, too many for the headset to render once you scan even a single room. So I currently need to, if I want to use this for visual occlusion, I need to figure out how to decimate these meshes. Once a person is done scanning a particular area of the room for a little bit, I can decimate these and reduce the triangle count, which kind of leads into another problem with the game that I wanted to solve, which was accurate visual occlusion. Because like I said, the depth API only works to about 5 to 7 feet accurately. And in these clips from these sessions that I'm running at my university, you can see some moments where you can see people's virtual heads behind walls when you shouldn't, like right over here. I can't actually zoom in here. That's annoying. but that person's head should not be visible. So I wanted to, fix these issues with accidental X-ray vision, which makes the game really unfair to play. And I could do this reliably with meshes, but and I experimented with several ways to use the volume for occlusion at greater distances than 5 to 7 feet. Or sorry, not feet, meters. But like I said, the if I'm using the meshes, it's just too many triangles. I need to find a way to decimate these, and I just didn't have time to get this done for the competition. Um, so what I ended up submitting largely was more of a proof of concept than a final update that I was ready to ship onto the store. But I still thought that what I was showing here was promising, at least, and a good glimpse into what I could accomplish with a little more time. So, and I'm also trying. There's one more update that I made. I think it was because I'm running these matches at my university. I've got like a dozen people playing at once, and I don't want to have a headset awake on my head the entire time. Or if I want to go get a drink of water or something, I want to take my headset off. But if I'm hosting the game on my headset, when I take it off, that pauses the game for everybody else, and I'd have to set up the server again. So I'm working on a desktop operator so that I can host the game on my laptop, and I can control what's going on from that without having to keep a headset awake on my face. So there's still a lot of issues and bugs to fix. I think I'm trying to find the bit over here where you can see somebody's. Okay, so here's another good example of somebody's head being visible behind a wall when it shouldn't be. And I've got an example, I think, somewhere over here. Yeah, here we go. This is using a downsampled render of the the generated environment mesh to do long distance occlusion. Normally, these lasers would disappear, kind of halfway along their path to my friend over here, and you wouldn't be able to see them hit the wall behind him. You probably wouldn't even be able to see his virtual helmet. But with the long distance occlusion, things are visible when they should be visible and hidden when they should be hidden. And I think in my simulator view here, you can actually see the downsampled render of that environment mesh. And I'm using a lower resolution render to try and compensate for the number of triangles that are visible in the scene. But it's just not enough to maintain performance after a certain point. So I do need to figure out that mesh decimation instead. But at least it worked up to a point, enough that I could demo it for this competition. So, and then here's the pathfinding zombies. Again, very rudimentary, and unfortunately, Unity's pathfinding nav mesh baking system. Again, I have to run it over too many triangles, so it proved not to be viable after you've scanned a few rooms. But the bare bones concept is at least still there. So as a proof of concept, I think it is somewhat viable. But yeah, issues that I need to fix. The biggest one right now is headset drift. I've wrestled with spatial anchors probably, I don't want to say more than anybody, but a ton. And I found them very frustrating because they don't actually anchor to things properly. If you walk away from the anchor and you walk back to it, it will drift and it won't snap back to where it's supposed to be. So even if everybody's positions are correct at the beginning of a match, by the end of the match, this is a pretty severe example of what can happen. But I need to figure out a way to solve headset drift. And I've been looking into things Let's see. Looking into some kind of dipping my toes into some work into this. This is a prototype using iterative closest point to match up two similar but or similar or different meshes of the different scans of the same physical environment. So this is something that could help, but this is a very simplistic algorithm that is prone to error. So it's not robust. It's not yet robust enough to use. Here's a slightly faster example. Yeah, there we go. So there are more advanced versions of stuff like this. Fast point feature histogram is one example where instead of trying to match up the closest points to each other, you actually create fingerprints of different features like corners, edges, etc. And you can, find if between two similar but different meshes, you can match up those corresponding features and match the models together. But I'm still wrestling with all of the math needed for that, so that's still a bit off. And by the time I figure all of that out, Meta will probably come out with some solution for anchoring down the headsets between or anchoring the headsets better. So I've also got a solution using fiducial marker tracking using the camera API. But I really love something that just works without any prior setup, and I don't want to force people to print out these giant fiducial markers, QR code like things, and tape them up around the room just to play a match. So I think that's my ramble. Let me know if you guys have any questions.
Perfect. Thank you. Any question from our panel here? Fabian, any questions to Julian?
We can't hear you.
Yes, we cannot hear you.
Sorry. Better?
Yes.
Okay. Yeah, great job, Julian. It's really amazing to see this. Thank you for also showing this here. Maybe I just wanted to add something because you decided to completely open source this project, right? So it's available on GitHub, MIT licensed. It's really great. So what was your thought process behind this to actually give this away as a super great resource for everyone to also look at what you do?
It's funny that I think I saw like one or two other submissions to the Devpost competition actually ended up using the depth scanning from this, which was kind of fun to see. But I think I just want this. I want this capability to exist on the headsets, and I want people to be able to use it if they can. It's very limited compared to Meta's official room scanning because you don't get the segmentation and the labeling. You only get just the shape of the room, the shape of the environment. You don't get any, this is a table, this is a wall, etc. Works in my case because I just need to know if an object there is there or not. But it's definitely not for everybody. But I thought it was just kind of such low-hanging fruit that should exist for a piece of hardware like this that it would be, a real shame if, I tried to gatekeep it because it really wasn't that hard to implement. The entire thing was explained in one Stack Overflow post. And I didn't want to. Yeah, I just wanted this to be able to be used by everybody. There is also a selfish reason, which is I think it would get more attention if it were open source. Because I think I'm trying to think back to the camera workaround thing. Half the reason I worked on that camera workaround was because I saw some post by somebody who had found their own workaround, and they were like, give me, 100 reposts and I'll, I'll tell you how I did this. And that just annoyed me so much, that sort of gatekeeping, that I was like, I'm just going to figure out a better way to do this. And I'm just going to, give it to everybody. And then that got me a significant amount of attention. And I thought, maybe this is actually a good way. I'm a university student, just getting started in my career. So I thought maybe this is a good way to, help spread the word about the work that I'm doing. Because unfortunately, the tech space is extremely competitive right now. So if a bunch of projects used, this project, and somebody noticed, hey, all of these projects keep referencing this guy in this game that he's working on. I thought that would also be, a good for me. So there is a selfish reason behind it, but I also don't want to gatekeep, and I want to see other people, if they have an idea that utilizes, or if they have a good idea and this can help them achieve it, then I don't see why I should guard it or anything.
Yeah, and you are creating your own legacy with that, right? So that's actually an amazing opportunity. Thanks, Julian. Like really, it's I can definitely tell that on behalf of the hackers and students that we are helping throughout the year, they are so much grateful of your work. And you are also explaining, like not only just here is the repo, try to survive with it. You are actually explaining. That's actually very nice, like a
I think actually I could do a much better job at documenting how everything
yeah.
works. So that's definitely something I need to work on.
Let's work together,
Um,
on that. We can definitely create some workshops together, etc., for hackathons, because uh, there are lots of hackathons we are organizing, so we can definitely make it already like something that, because as long as people, you can give like a workflow to people, I think it's much more easy for them to grasp whatever you are releasing publicly open source. So that's a great opportunity. Thank you, Julian, for your time and your congratulations again for this success. Hopefully, we will see you in another project or another opportunity as well. But thanks for making this possible. And then I think now Fabian is next, right, with the amazing Band Together project. Fabian is also one of the first cross-platform co-location, I would say, innovators in the space. Back even HoloLens times, he has been working on cross-platform multi-user experience collocation. So now we will see a little bit different, of course, project, but yeah,
Right.
Fabian's project is also very interesting. Maybe you can share screen, Fabian.
Yes, perfect. Let me share my screen quickly. First of all, the majority of the credit for this game goes to three of our team members who are also just like Julian studying. They're studying game design here in Berlin, and so we decided together, let's do something, let's say, really challenging, so where they can kind of excel in what they love to do, and then learn something very new, which is getting into a VR game under time pressure, and just come up with a cool idea that incorporates new features and is in the end fun to play. And I'm super happy. Thank you for letting us share this experience. Quick disclaimer, Band Together unfortunately did not win a prize, but if you take a look at all the competition, it's amazing to see how many high quality projects have been submitted to this hackathon. So I'm absolutely not
maybe it will be a
Okay.
similar situation like Julian's, right? Apply with same next year. Maybe it's then the time is maybe next year, right? So
Yeah,
that
absolutely.
so
And in the end, it was really worse, the whole experience. I'm not sure if you can see my
yes,
screen.
we can see Unity project, I guess.
Um, yes, exactly. So I just quickly wanted to guide you through the thought process. Maybe as you can already spot on the top left corner, we have been evaluating and looking into the amazing GitHub repository of the Oculus for now, Quest crew. And there are a ton of projects where you can actually get started with a basis that you can then modify, either completely modify or just take parts out of to come up with your idea and during the creative process, create fast iterative prototypes, iterate over different ideas, and then just get started to quickly come up with something that in the end works. So the first thing we looked at, and that's why I switch over here. I maybe first of all, what is Band Together? So Band Together is a fast-paced VR game for the Quest 3. I'm not sure if the sound is also coming through.
No, we
No, it's
cannot
not.
hear. We cannot hear. So you need to share the sound. Maybe reshare the screen.
Yeah, let me quickly try that. Mm. Here it is. Okay, perfect. I'll just try again.
Yes.
Very nice. So the general idea is to have micro gestures and combine it with the learn and play so that you can play a Beat Saber like or Guitar Hero like game anywhere. So standing or sitting, it doesn't matter. It works with a minimum amount of movement. That's still a lot of fun. Yes. So the general idea we started with evaluating multiplayer stuff. That was our first idea. Let's do a multiplayer based game, and everyone who's been doing multiplayer, starting with multiplayer and then doing it in the let's say very fast paced environment of a hackathon. Not always the best idea to go forward with. Nevertheless, we started exploring some of the hidden gems in the GitHub repositories of Oculus, and one of them, which I can highly recommend that you check out, everyone, is Spirit Sling. This is a tabletop-based game, multiplayer game for up to 4 players, where you are in mixed reality and everything is actually predefined for you. It uses a photon to handle all the multi-user stuff. It uses the avatars, meta avatars, so you can even see the other people around you. It's a very nice, super high polished game, easy to learn, and it's fully open sourced by Meta, so you can actually grab it, implement your own version of it. It's probably the best way to start a tabletop game. So we've been looking at this, but for starting, it's a little bit overwhelming, and we've been also trying to set it up on different development environments, like a laptop with Windows, and then we had a bunch of developers who work on the Mac ecosystem, and that was one of the things where we spent a couple of days just figuring out how to make it work, run, and compile on all of these machines in the Unity environment, which is not as easy as it may sound. One of the other, I think, issues that we currently see with existing GitHub repositories is they do not age too well. So as you can see there, 5 months ago, this is the latest post where it was updated. So you have to invest a little bit of time, even though it's a really great source to get started with. Still, you need to figure out, is this the right way to go for your game, or do you start from scratch? But as an inspiration, this was a really great start. We quickly found out that the core concept of the game can easily be done with a different example, which is Move Fast. It's even older. Was kind of a punching game where you had a lot of elements already in there, music, rhythm, punching game style. So this was a great start for us, so that we can actually focus on what we actually do best, make a conversion, get everything in there from UI, UX standpoints, and especially iterate and try out all those new micro gestures that had been introduced earlier by Meta. So we focused completely on, can we integrate the micro gestures? There are 5 micro gestures which you do with your thumbs on your hands. Just swipe left, right, front, back, and then also tap. And you can do this with both hands. So it's a pretty neat and easy to use feature of the Meta SDK. So we fully worked on that. Once we had the core concept of the app developed, there was one thing that we really wanted to match. We bought one of the songs to also support, of course, the artists. We bought the license of a song called Mania Master by an artist called Lucas Nocte. And then just based off of that, we created this, let's say, demo track for bands together. The one thing that's really interesting, and that's why we explored this, you have to create this beat map, right? So that you can actually have this track and the notes or the beats are flying towards you. You have those symbols where you know where to swipe and so on and so forth. But how do you actually create such a beat map? And this is where we decided to just develop a little helper tool. And this got a little bit out of hand. As you can see, I'm already here in the Spotify. So we created a web-based beats map tool, which is completely standalone and allows us to either load a MP3 file. Here we have the MP3, right? And it just loads in the stuff. You have a fully, reactive timeline scrubbing system. And then you can just, for the left hand of all the beats, because we have 5 different ones, just have it on one part of the keyboard. And then for the right hand, you have the right hand part of the keyboard. And it was just very, very cool to have it. So you could just get started. Yeah, I won't go through this, but there's a lot of things to it. And the cool part is we then decided, well, what would be cool to have a source for unlimited songs that everyone wants to see and wants to play on. And then we just built in a connector to Spotify so that I can actually, link my account to it and then just head over to Spotify, find a song that I want to use, and then just copy the link to the song and simply paste the link in here. And then here we go. We do not get the actual wave because that's limited by the API, but still we have every information that we need for creating the song. And there you have it, right? You can store the link together with your bitmap, and then just upload it to your game. And this is a feature. This will definitely be integrated into the VR game as well, having the connector to Spotify as part of the game, so then you can connect to your Spotify account and then just play any song from your favorite song list and create your own beatmaps or share them with the community. So that was really fun, and I think, made this app hopefully a longer lasting experience. Yeah. So that's actually all I wanted to talk about for Bitmap Band Together. Probably one of the things that I would love to add is, of course, the multiplayer feature, so that you can play together with others. But that's for later. So any questions?
Thank you, Fabian. It's very nice that you shared another interesting with the all the behind the scenes. Sometimes we are just looking at the dev post pages and the videos, but it just shows the tip of the iceberg. So what you are showing right now is much more like helping us understand your process, your workflow. So I have one question. By the way, we also shared the sample and the dev post page, so people can also look at that. There's actually one question. Let me first ask that from Mac. Um, did you use the Spotify playlist of the logged in user in the app?
So currently, the Spotify connection is only available in the online tool yet, but the API allows us to also do this inside of the application. So this will be one of the next things to do, so that you can actually see your playlist or even compile your own playlist. Right, but there's no automatic beat mapping. So this is the one thing that you have to do yourself. But with the beat mapper tool, it's pretty straightforward and also fun to do.
Okay, great. And how do we create these rhythm-based games? And how do you map it to the beat?
Yeah, so
Any short answer to that? Because it's especially mapped to the beat is a very, as far as I heard from other rhythm game based game producer, it's a quite actually it's not as easy as it is seen. Maybe it's actually a much complex system behind. But anything you would like to give as a some tips?
yes, my I think my best suggestion is to also take a look at the Move Fast repository. This is a fully working thing where action items are based to a specific rhythm of a song. So it's a great resource to get started. The way that we extended this is that we've created those externalized. Maybe let me quickly, very, very quickly share my screen again. So we in Unity, we've created something. There's actually the song definition itself is just a scriptable object, and we've extended the scriptable object with a editor helper that lets us import and export JSON files. And the JSON file contains, kind of the timestamp at what point is it actually going to happen. In this case, for the song, which is 2 minutes and 40 seconds long, we have 155 beats. It's very simple setup that lets you actually map that to a timeline, and then in Unity just use the timeline to then map some events to it, which of the items should be spawned, and then it's very simple because what you have to do is just map the input to the specific event and then match it or compare it to kind of a range inside of the timeline so that you can see if the person hits the beat at the right time, or if it was slightly off. And then, of course, which of the gestures was used. Regarding the mapping, and that's why we decided to go externally. You could easily, of course, try to map it just with the right beat and so on and so forth, but this is horrible to do. So after watching one of our implementers here for the game do it for 2 hours and then only having I don't know 30% of the song ready, we decided to create this beat mapping tool. And this is honestly, as you can see, it's a HTML-based tool with some JavaScript inside of it that utilizes a lot of JavaScript frameworks to give us a timeline and all that stuff, and then easily map it to the keyboard, which then creates those JSON files that I can import and also save, and then import it to Unity again for straightforward pipeline. Long answer, sorry.
All good, all good. Yeah, also there was Richard also gave some direction as well. So that's great. Perfect. So yeah, I mean, maybe one final thing I can ask quickly is then you imagine this future of a little bit entertainment consumption, right? Like especially now Meta is also doing a lot of immersive entertainment stuff, like how we will listen to music, how we will watch like movies, TV streams, right? Um, Anything that you would like to share with us, like how you are imagining, if you see a full blend of, let's say, we are not maybe like a directly headset, but like you are having a wearable, how you imagine that we consume an entertainment content. Are you seeing like um, we are going beyond what we can already do with Spotify, or is it something that you believe that can be something else that we have not been used to so far?
Yes. So I think one of the cool things that Spotify already kind of provides you with is this personalized experience and having access to so many songs. And because they have an API that I can tap into as a developer, I can link this to extended content based on existing entertainment content and then just modify it or augment it, so to say, with whatever I can make use of in the hardware that I use. So, for example, for the Quest or for VR headset, you could even use, for example, Julian's real-time meshing algorithm to maybe have something interactive happening to the music that you're currently listening to, which would be pretty awesome. We've also seen those amazing projects where you have just a video or a movie that is also augmenting your environment with special effects and so on and so forth. And all of this leads back to one simple element, which is, am I able to tap into the actual timeline of a already existing framework like a Netflix show or a YouTube video or a Spotify song? And can I then link it to extended information that I can store in a JSON, for example, or any other way so that I can relink it inside of my application to more entertaining content. And this, I think, we will see in the future more and more often. Yeah, at least I hope so.
Yeah, definitely, definitely. I think this syncing can be a very interesting thing that you can maybe even make it part of your daily activities, daily life. Imagine that you are cooking and you are listening a Spotify song, and basically the objects or environment that you're interacting with is basically feeling or beating with you, like while
Mhm.
you are doing. I think this kind of things might be very interesting. It's also a little bit like part of manipulating reality, like the thing that we discussed with Lucas, right? I think I feel like there might be some convergence that we will see here, how we consume entertainment with maybe in a much more playful way, doing some chores playful way. So thank you, Fabian, for your time and then this interesting project. I think this will give
Yeah.
us a lot of perspective for future entertainment or like a beat focused projects. And now we have the last project coming up. Parker, thank you for joining us today.
Thanks so much for having me, Farhan. Really cool looking at some of the other projects and getting some of the insights into how everyone's doing it. Um, it's just really exciting to be able to look at and say, wow, you can just jump in with these tool sets in a month and like get all this stuff going. So yeah, thanks again for having me. Quick introduction. I'm Parker Howell. I've got Howell XR. We're a studio out of Austin, Texas, and we are building experiences for people that are basically at the convergence of entertainment and human flourishing. And for most of the year, about 90% of the year, we're working with other clients, helping them build things that no one's ever, done before. And then for like 10% of the year, we have time to go and work on our own projects and build out pieces like
Passion
that.
projects, right? Passion projects.
Oh, you got to have the passion projects, because like the clients come to you and they go, okay, we want this thing. And you start working with them and it just keeps getting simpler and simpler. And you're like, oh, I want to do my own thing where I can, take us into the deep end and play around.
Or push the limits, right? Because you have something in mind. I agree with you. I think these competitions and hackathons is like an interesting environment that you can really build what you have been thinking of throughout the year, So I think it's a very nice. And your project is also very interesting. Language learning is very interesting. We have seen a few examples before, but yours is also approaching in a very nice way. In the again, I would say vision, seeing having a contextual understanding is very important. So we would love to hear how you managed to finish that in such a short period of time. What are the tech stacks you used? What are the challenges? So maybe if you can explain in the next 10, 15 minutes. And we also shared the Devpost link so people can also check in the meantime. Stage is yours.
Sure. Awesome. Let's do a screen share real quick. So everyone can kind of see what we're talking about here.
If you want, you can share sound so we can hear that as well. You
Oh,
just need to,
you're not able to hear it currently?
yeah, you just need to reshare. Just on the right side, when you are sharing, there's a share sound
Share
button.
sound. Boom. Great. All right.
You just need to close share screen and then open again. It will be
Okay.
immediately seen on the right. You will see a share sound button that you need to click that.
Share sound. Boom. Let's see.
So when you share screen, it should show up before you select the screen.
Working?
No, we
Nope.
don't hear. Did you click that share sound on the right when you
I
are
did.
sharing screen?
I did. Share sound. Boom, boom.
On the when you click the share screen, you will see you are selecting the windows, which window you want to show.
Welcome to
Yes,
Language.
Working?
perfect.
Great.
Yes, perfect.
Welcome to Language IRL. I'm your tutor, Mono Bonobo, and guess what? The whole world is now your classroom. Put down your controllers and pick up a new language with me. Complete lessons by speaking the words out loud. You can also navigate by pointing and pinching. Need help? Give me a thumbs up. Want to skip something? Thumbs down works great. All right, let's start learning.
Taza.
Taza. Botella.
Botella.
Botella. Cup.
Taza.
Señal de stop.
Señal de stop.
Señal de stop. Lleva un bolso al autobús.
Lleva un bolso al autobús.
El banco junto al parque es antiguo.
El banco junto al parque es antiguo.
Cool. So yeah, so that's language IRL. The basic idea of it kind of came to us almost about 8 years ago when I was first getting into the virtual reality space. We made this VR film called Confucius VR, where you have this like augmented reality AI sensei who's teaching you how to level up your life. And I remember back in 2025 when the pass-through camera access came about, I was like, okay, well, now that we have that, now that we have, these big LLMs, like if we can basically connect them, then we can kind of bring that experience to life in a real way. So we basically, when the Meta Hackathon popped up and we said, okay, I think we have enough time set aside where we can work on this project, we kind of looked at all the different ways with which we could kind of merge those pieces. And where we landed was on the language learning app, because we looked at some of their sample projects that they had, and just with that kind of internal, it was that YOLO model with Unity Centis, is it was able to show you the objects and identify them, and then give you that kind of spatial anchor to find them and figure them out. And so we kind of started there and we said, okay, this language learning has become really popular with like Duolingo and all that. And so we're like, well, let's kind of like work through like on paper, like what do we think the tech stack is to go and make something that's like really useful that helps people learn. And I guess the other piece of why I think it's so cool is what you really want with language learning is immersion. Flashcards are great, and it's a step in the right direction, but your brain is really connecting all the dots when it is like engrossed in it. And so like having the physicality of the world around you and having it translate, we find that it really helps you to retain the information. But so yeah, we just kind of went through and we said, okay, well, like what's this tech stack? Basically, we need to be able to identify the objects, have the spatial anchors. We're going to need to figure out how to do the speech to text, text to speech, and then some kind of analysis of how good your pronunciation is and all that. And then kind of on like the longer tail of the piece, we wanted to see if we could connect it to an LLM where we could basically, whatever the world is that you're inhabiting, have that LLM build custom lessons for you. And so when we kind of pieced it down to those different pieces, we started with saying, okay, let's first just work with these individual pieces by themselves, make sure all those pieces work, and then bring them together. And using Meta's own sample project, that was a great start just for the anchoring, for the object identification. And that got us like halfway there. And then we realized that Azure services was able to handle all the speech pieces that we need. And so we just kind of went through one by one saying, okay, can it translate this language? Can it translate that language? And what we found is like, this is actually a really robust system where we could basically do as many languages as we wanted. And so having all that tie-in was really sweet. And we this kind of MVP that we put out, we did Spanish, French, and German, but it's kind of funny because like now we're kind of gearing up for a trip to Japan. I'm like, okay, well let's put Japan in there so we can start practicing at home. But basically, yeah. So we took all those different pieces, made sure they were all working, and then kind of came the hard part of just putting it all together, making sure one thing was talking to another. I guess the other piece was that Azure was able to handle the LLM support as well. And where you see that in that current MVP that we have is kind of in that last section where when you point at objects, it will give you a sentence around how to use that object. And so really all these pieces together are working really nicely for this little language learning project. But I feel like the potential for all this, the potential for using that camera access to be able to send images and send them to and from the LLMs means that, you know, we could use this for language, but we could use this for all sorts of different kinds of training and learning and human flourishing, as we say over here. And so, yeah, those were the main pieces. The team was pretty small. It was me and Rico Balakit, our lead programmer. We do a good job of kind of complementing each other, where I'm a decent coder, Rico's a great coder, and I'm a solid designer, and Rico also has all the design chops. And so kind of going back and forth, we were able to just kind of build it gray box and then start putting the design elements in. And then, you know, it's like 48 hours before the things due. It's like getting all the little polishes and then just honing all the little pieces from like hand gestures to making those feel smooth. And then kind of taking some of the pronunciation and just making it, making like the thresholds for those simpler. Because if you make those really tight, you know, it's always just going to tell you, no, you didn't quite get it. And we didn't quite have the time for this MVP to have it say, no, this is this specific word that you missed, and this is how to say it and get it dialed in. But I think that level of granularity with this tech stack is possible. So yeah, that's basically where we're at with it. And you know, winning the, you know, camera access with AI was really awesome. That was a really cool piece for us. This is one of the second hackathon that I've been a part of. So that was cool to be like, okay, this is some recognition that we're going on the right way. And I think where we're at with it right now is we're just kind of trying to figure out, is this the platform that makes the most sense as far as launching this? Or is it something more like the Orion glasses? Because like one thing that happened at the end of it is like after we built the whole thing, I had to run around downtown Austin with my Quest 3 on, you know, doing language lessons. And, you know, we're just not exactly quite there, like socially, for people to be running around with Quest 3s on without getting a lot of strange looks. But maybe with this kind of new era of these smart glasses, it could be something that would be a little bit more incognito and be a little bit something more mainstream. So yeah, that's kind of the journey of the whole piece. And yeah, I'd love to answer any questions you guys have about it.
Amazing, amazing. So I don't know if anyone has any questions. I have one, but Fabian, two questions or
No, no, no,
one.
it's just one question.
Okay.
So first of all, amazing. It's perfect. I love that you used Azure Cognitive Services there. In regards to the latency, because you know, pointing at stuff and then I don't know, maybe there's some, you know, image recognition to it. How fast was the turnaround time? Is it actually real time that we see in the trailer?
So yeah, so latency. I guess the two main like technical pieces like that like if you were to sell this as an actual product, you want to dial in as like the latency and the accuracy, for
Hmm.
sure. But like as far as pointing at things goes, the way that we identify all the objects in the beginning, those just get anchored there. So as far as pointing at them and all that,
Nice.
though that is all saved from the beginning of the lesson. So pointing at them super easy. We opted not to have it like continuously updating, just
Hmm.
because it helped us with frame rate, it helped us with a few other things. Um, there is like when you get to the final lesson, which is sentences inside the app, it does take, you know, about a 20-second loading time when you enter that app where it's building the entire lesson and it's kind of like rendering out all that audio and storing it.
Hmm.
And we had a conversation about like, hey, can we get that as a background process going on earlier? And then the answer is yes. But the answer is, can we do that in a month? No. So we're like, okay, cool, 20-second loading time. But once that's loaded in, everything is pretty responsive. I
Nice.
would say the when it's kind of grading your pronunciation, that usually takes about 4 to 5 seconds. And so or sometimes less. Sometimes it takes about 1 second. You know, it's kind of all in that area where I'm like, this is not terrible, but you know,
Hmm. Perfect. Nice.
Yeah,
Thanks for sharing the insights.
absolutely.
Wonderful. I mean, Lara is one of the language learning app creators as well. I don't know if she has any questions.
I
She
do.
was also
One,
working on that before.
just you used Azure. So did you find it as that worked the best? And also, like, if you plan to launch it, then how the pricing, like, or how will like it would be expensive, right? If it goes to public, how would you
So
solve that?
yeah, so great question. Part of what was really fun about this was just trying to figure that all out, and we just started doing it, and we're like, okay, we're signing up. How much money is this going to cost? But in our whole month of development, I think we spent like $1.17 in Azure tokens. So I was like, I'm imagining that, if we go and put this out as a product, you do subscription based because you'd need some kind of token system that's going throughout the piece. But I think at that price, it's doable. Duolingo. I know I'm on it with some friends. It's like, I don't know, $40 a year or something like that. But I think that would be viable for an app like this.
Thank you.
Yeah.
Perfect. Let me check if there are any other questions. Great. One question maybe, what would be how you imagine like we will explore language learning because it looks like we are a little bit going to the level of like you saw these Ray-Bans features, etc. They are really live translation will become a thing. So how you are imagining, like I'm just asking from a use case perspective, do we need will we need like a language learning in a way that we have been needing before, or people will start using so much live translation so they don't need any other like a language to learn anymore? Like I'm just trying to I'm a little bit worried that will we have enough incentive, our next generations maybe will have enough incentive to learn a new language or not. What's your perspective on that?
Yeah, I think like with regards to learning anything, there is like that innate love of learning it. And there's that innate, love of the process of doing it as well as the benefits. And like the first benefit for learning language is like, cool, I can talk to more people. But I think it's also the case that like it expands your mind to learn something like that. You,
Definitely.
you look at a different language that they have words for things that you don't even have a word for, and suddenly your brain's kind of open up to these new signals and these new pathways. So um I don't know, maybe for some people walking around with translating glasses will be good. But I kind of think about it as like if we did have it functioning really well on Orion, it's kind of like when I'm going throughout my day and I'm listening to my podcast and I'm learning that way. It's like imagining going throughout my day with my glasses on, and learning, in this kind of spatialized contextual way. I think that's like really exciting. And so, yeah, I just think that people are going to want to learn, and maybe things will be easy, but there's always going to be something to challenge yourself with.
Uh, my perspective is a little bit still most of the language learning apps is a learning app, right? I think what we need is more like a Copilot app, right? Like how we can make it almost like because programming languages, right? It's also a language, of course, completely different. You are basically having a Copilot that's actually helping you along the way, right? So, of course, you can now convert ChatGPT, etc., towards a little bit much more like help me while I'm talking. But if we can create a much more seamless thing, and also it learns from the world together with you, if we have like extension of our eyes, our ears with the help of Ray-Ban type of smart glass, AI glasses, I feel like there is an I think the future of Duolingo type of things will be more like a co-pilot type of thing that I'm learning together with my um, assistant, like I think that might be interesting rather than oh today's lessons are like okay we are learning this vocabulary etc but instead let the AI agent be part of the conversation, helping you, or be part of the writing, but in a much more proactive way rather than, or let me teach you or let me fix your things. I think that might be something that I believe that we need to wait for maybe next few years.
Yeah, I think that's really exciting about this approach for it is opening up simulation space for it. Once you go in and you've learned all the lessons around, ordering from a restaurant, to sit down and instead of having the monkey just teaching you the words, he's sitting there as your waiter and you're having a conversation with him, and then he's kind of going, okay, well, here's where you said this, and that's, formally correct, but here's another way of thinking about it that might be more suitable to the scenario that you're in. I feel like the more that it's fluid, the more that you're just totally engaged in something that resembles actual conversational language. I think that's when you're going to see this stuff being really powerful.
Exactly. I think it's really exciting that we are combining contextual understanding with these apps. Um, so thank you. I mean, this is amazing. We really have learned a lot in this maybe 90 minutes of session today from 4 projects. Thanks for joining us as well. Like this, I think language apps will be really very like um, I would say no-brainer, like we need language learning apps in any device we have. I think there is whatever medium it is, we will somehow need this, and we have learned a lot from a lifestyle app perspective, like how you are actually bringing these together. Thanks for joining as well. I think we are quickly, maybe if there's any no more questions. Lara, have you seen any further questions, or we answered everything? Perfect. So I think, yeah, for today we are wrapping up, but we may have a few more sessions like this. If you enjoyed, please give feedback and then share with us so we can do a few more sessions, because as you can imagine, there's 655 projects in the whole competition. We cannot cover all of them, but at least we can curate like we did today. So it's also a nice opportunity for builders to express themselves, share their perspective, and we learn from them, and then maybe create something based on this inspiration. So yeah, Laura shared our Eventbrite page, so you can always sign up. And thanks everyone for joining all the 4 project teams. Hopefully, we will see even further improvements to your existing projects, and then we will see maybe different, again, unique use cases from you guys, from apps from you guys, and then we can also enjoy um, maybe experiencing these things in the next couple of months. So thank you, everyone, and thanks everyone for joining, and see you in the next open lecture and next say and tell and play together event.
Awesome. Thanks so much for having us, man. I really appreciate it. This was fun.
That was really awesome.
Thank you.
Bye-bye.
Bye
See you
bye.
guys.